Right, this is a 2018 Peugeot Kisbee. So this is the latest model with the fuel injection. This is actually not my bike, this is my friend's bike. She bought it not that long ago, and she basically asked me to de-restrict the bike. Um, at the moment, I haven't seen any other YouTube videos or any hints or tips on the internet on how to de-restrict these fuel injected models. So I'm going to kind of talk you through the process. The previous model was very easy to do. You can just do it through the CDI units. This is the latest model, and you'll notice this has the LED daytime running light there, and also if you open it up the storage, you'll notice there's a OBD2 diagnostic port, which you'll get in modern cars. Okay. For some reason, I plugged in my scanner, which I use for cars. It didn't seem to read the ECU, so maybe you need to get something that's specific to Peugeot or scooters. Okay, to de-restrict this, basically we need to take this cover off, and I'll show you how to do it. Okay. Okay, now that the cover is off, first of all you'll notice there's a little sticker there saying injection technology. So you know the scooter is fuel injected. There's a cable on this cover here. Basically that connects to a Hall effect sensor, which basically measures, it reads the speed of the bike, and it feeds that signal to the ECU. That has no effect on the speedo at all. So what I first tried to do was this cable. It kind of runs back there, whether you can see there's a connector just there. I disconnected it to see whether that would work. The bike would run. I got up to about 20 miles an hour, and then the engine light came on, and basically the ECU put the bike into limp mode. So it knew something wasn't quite right, and to prevent further damage, it just basically put the engine into limp mode. Okay, so I couldn't go any faster than 20. What you notice here on the clutch bell, you have these little tabs here, and there's 4 of them on the clutch bell, and that basically is for the Hall effect sensor. So the ECU can measure exactly how fast the rear wheel is rotating. Okay, so what I've done, I've basically manipulated this clutch bell. I've there's 4 of those magnets on there. I've basically used a little Dremel tool. You can use an angle grinder to remove 2 of the opposing magnets, so that the clutch bell is still balanced. You can see I've taken that one away, and I've taken the opposing one away as well. Okay, so in theory, the ECU will only record half the actual speed. So the recorded speed is only going to be half of the actual speed that you're doing. So then I put it all back together. I thought it would be fine. Again, the bike was restricted to 30 miles an hour. So I'm back to square one again. So took the cover off, and what I thought might be happening is that because the magnets have been on there, maybe the metal's still kind of magnetized, and it's still getting that weak magnetic field is still getting picked up by the Hall effect sensor. So what I did on the Hall effect sensor, you can see, is it's held on by 2 screws. Okay, so I've removed 1 screw, and I've shifted the sensor at a slight angle, and that's held down tight by the other screw. Okay, you can only remove this screw here because here there's a ground connection, so you need to keep this screw on, but it's tilted at a very slight angle now, so it wouldn't pick up the weak magnetic field from these 2 points where the sensors used to be. So it's only picking up the magnetic field from these 2. So it's as simple as that. Put it all back together, and I managed to get the bike to record, what did I get? 45 miles an hour. on the speedo, but obviously speedos are a little bit optimistic, as in all vehicles. On the GPS, I recorded 41.5 miles an hour. That's with a little bit of help from gravity, but I can show you those recordings in a second. Okay, that's it. Thank you very much for listening. Bye bye.